Audition is also known as the sense of hearing. The sensory organ involved in hearing is the ear. There are three regions of the ear. There's the external ear, which is the part of the ear that we see, the middle ear, and the inner ear. In order for hearing to occur, sound waves have to enter from the external ear and then be transferred through the middle ear into the inner ear. So let's start by taking a closer look at the structures of the external ear. The auricle is the part of the ear that you probably typically just call the ear. So it's the part of the ear that you can see on the outside of the head. The external auditory meatus is the ear canal, which runs through the temporal bone of the skull. And you can see that here. And then the tympanic membrane is also known as the eardrum. And the eardrum is the boundary between the external ear and the middle ear. The middle ear is located between the tympanic membrane, which is the eardrum, and the oval window of the inner ear. And between those two structures, there are three very small bones called the auditory ossicles. And the three bones that are there in order from external to deep are the malleus, the incus, and the stapes. And then the stapes is in contact with the oval window, which is up against the boundary of the inner ear. The inner ear is connected to the pharynx, which is the throat, by something called the eustachian tube, and or it's also called the auditory tube. And this is the tube that is involved when you pop your ears. So if you're in an airplane or if you go up in elevation and you notice that there's pressure behind your eardrum, it's this tube that you can kind of open up by either moving your jaw or chewing on gum or something that can open up in order to allow that pressure to equalize. Now, in small children, this tube can be very small or underdeveloped at first, and so if the tube is not working properly to drain material away from the ear, fluid can back up here and get infected, which is what causes an ear infection in small children. So oftentimes in small children, they put a tube in the ear, and when they put the tube, they actually put a tube through the eardrum. And that allows fluid and kind of other potentially infecting agents to drain out of the ear through the external auditory meatus, since it can't drain through the eustachian tube. Once that eustachian tube develops a little bit more, the tube from the tympanic membrane can be removed, and then it typically heals over. In the inner ear here, we also have the cochlea, which looks kind of like the shell of a snail. And this is where the actual sensory receptors for hearing exist. And it's filled with fluid. And there's a special structure called the organ of Corti located in the cochlea that contains hair cells. And the hair cells are what bend when sound waves enter through the ear and reach the organ of Corti. So we've already talked about the structures. Now, how does the sound waves, how do they get from outside all the way to the organ of Corti inside the cochlea? So first of all, the sound waves travel through the auricle and then through the external auditory meatus, and then it causes the tympanic membrane to vibrate back and forth. As that tympanic membrane vibrates, it moves the malleus moves the incus, and the incus moves the stapes. The stapes then pushes on the oval window, which is attached to the inner ear, and there's fluid inside the cochlea. So as that stapes is pushing on the oval window, it is transferring those vibrations to the fluid in the cochlea. As fluid in that cochlea moves, membranes in the organ of Corti move, and they bend these little hair cells here. These bent hair cells can then send action potentials along the vestibulocochlear nerve to the brain. Now we can hear different pitches and different sounds because different wavelengths of sound trigger different areas in the organ of Corti. And this is why some people, actually as you get older, you typically lose the higher frequency of your hearing. So humans can typically hear from 20,000 hertz to about 20 hertz. So 20,000 hertz is a very high pitch. 20 hertz is a very low pitch. And as we get older, we start to lose the higher frequency or the ability to sense these higher frequencies. And that's because the sound energy hits this area first. And so these are the hair cells that typically get damaged by things like going to a rock concert or listening to your music too loud and just day-to-day sounds as well. So the younger you are, the higher the pitch you can hear. As you get older, you stop being able to hear those higher pitches. This video, you should open up the PowerPoint and watch it, and it's especially fun to watch with a friend because it does a kind of pseudo hearing test where it plays different pitches of sound waves, and you can tell whether you can hear it or not. So it's fun to play with someone who is especially a different age than you, so someone significantly older or significantly younger, because a younger person is going to be able to hear more of the sounds than an older person will.